So firstly, create a, just close this dialog. Okay, go to file and new, and create a new project. So created new project, you can put your project name. Don't add any special character into project name because it's gonna create a error. You can change the location of your project saving location, and then create directly specified, click yes on it. Now new app project window is created. Now you can create a schematic here. So to create a schematic, the components palette is given above. To create a transmission line, we need a substrate. Go to tools, here create a transmission line and press the OK. Now a substrate creation window is generated. At the substrate height h 1.6 mm, dielectric constant 4.3 in case of FR4, Z0 is 50 ohm, and electrical length is 180-90 degree, because electrical length change only the phase shift. Now you can do the synthesis. W and L for the transmission line is generated. Now we can export this substrate by using this icon, export substrate. Now exported substrate is exported in schematic, and again open that window. Now export transmission line. So from here we will export transmission line is exported to the schematic. Okay, now we have to connect the microwave port to the one end of the transmission line. So connect the microwave port. Now this dialog box is open, the 50 ohm micro port, press the OK. Now for another port also we need another microwave port, so we have dragged another microwave port from the component palette. Now we connect the microwave port to the transmission line through a wire. To connect the wire, press the left click and then right click and then leave it. Left click, right click and then leave it. So to set the frequency, take a frequency box. Here you can see start frequency, stop frequency, and frequency steps are given. Start and stop frequency here are 1 gigahertz and 5 gigahertz, and the steps I given here is 100 megahertz. You can set accordingly. Do the analysis. Now the analysis is done. Go to the reports and go to the reports editor. So from here you can plot whatever you want. We will take S11 in dB. So for numbers we have selected S11, response is S11 in dB, add and display. Here you can see S11 is plotted, return loss is less than minus 40 dB throughout the frequency 1 to 5 gigahertz. Now we can close this. Here we check the S11 only, we can check the S21 or S12 also. So again you can go to the reports, and here you can add the S11 and S21 as shown in the video. Let's go to the reports again. So here is the reports. Go to the report editor. Here we will select the dB, and then we'll select the S11, add, and similarly for dB we will select the S21, add, and then display. So here we can see the S21 is 0 dB, which refers that the complete power transfer from first port to second port, and there is no reflection. It can be proved from return loss is very less than minus 50 dB throughout the frequency. So the next experiment is 50 ohm load transmission line. So again come to the schematic window. So we have to connect one end of the transmission line for 50 ohm resistor. So just delete the microwave port and get the resistor from the above palette. So add a dialog box will be open when you drag the resistor from the component palette. So here you have to add 50 ohm. Just write the 50 ohm. So 50 ohm is done. You can press the OK. Now we have to connect the resistor and to the transmission line, and other port of the resistor to the ground. So get the ground from the above palette and connect it to the through a wire. So the complete schematic is done. Again Before analyzing, save the project, go to the file, save. Now we have to do again analysis. Analysis is done. Again go to the report editor, and repeat the same process as was done in the first experiment. db s11 add. You can also check the magnitude of the s11 and magnitude of the VSWR, and other parameters are also given here. You can check whatever you want. So here I have added S11 in dB in magnitude and as well as the VSWR. You can see all the three graphs are given in the same graph. So you can change the graph properties by just clicking on the axis, left click, and you can change the color, font, you can change the scale. As I am changing the scale from 0 to 100 dB, and you can change accordingly. So now come to the next experiment. Next experiment is open-ended transmission line. So in this we have to left the one end of the transmission line open. To do it, just right click on the resistor and delete it, and you can also delete the ground, or you can left it open. By leaving ground as it is in the schematic is not gonna change your results. Okay, so again the same process. Firstly save the schematic and then do the analysis and then generate the report. So a error window is generated that one end of the transmission line is left open. Press the OK and do the analysis anyway, and go to the report and report editor, and again you can check the S11 in dB in magnitude and VSWR. Here you can see the magnitude of the S11 is 1, that is the reflection coefficient is 1 for open-ended transmission line, and in dB S11 is 0 dB, which is well matched with the theoretically calculated results. Now the next experiment is short circuit transmission line. So to do that we have to connect the one end of the transmission line with microwave port and another end of the transmission line with the ground. So connect the open end of the transmission line with the ground. Drag a ground from the component palette to the schematic and connect it to the open end of the transmission line. Again save the project. Always save the project before doing the analysis. Now go to the report. As I have not done analysis here, so an error is generated. Analysis must be performed before report editor, so press the yes. Now you can again generate your S11 and VSWR report. And here also we can see the magnitude of the S11 is 1 for the short circuit transmission line, and in dB it's 0 dB, which is correct. Next experiment is to connect a reactive impedance at the one end of the transmission line instead of a real impedance. So for here we are taking a inductor. Drag the inductor from the component palette, add the value. To add the value you have to add the unit as well. So here we are added 1.99 nanohenry. which is the L value. To calculate the XL value, XL is equal to j omega L. L is here 1.99 nanohenry, and omega is 2 pi f. F you can take 2.45 gigahertz. Connect the one end of the inductor to the transmission line and other end of the inductor to the ground. So the schematic is done here, and again the same process, save, analysis and generate the report. Now the next experiment is to connect a complex impedance at the load of the transmission line. So inductor is already here, we will connect a R plus XL. So we need a resistor, drag a resistor. So the impedance value we are taking here is 50 plus J25. 25 is a XL value. From there you can calculate the L value. XL is equal to J omega L. L will be 1.65 nanohenry. Here I have changed the value of resistor and double click on the inductor and change the value of the inductor to 1.65 nanohenry. Okay, now connect the one end of the resistor to the transmission line and another end of the resistor to the inductor, and similarly connect the one end of the inductor to the resistor and other end of the inductor to the ground. Now the complete schematic is ready. Repeat again the same process, save, analysis and generate the report. A error is generated because one end of the transmission line and the resistor is left open. So be careful and check all the connection before performing the analysis. These are the results. If you have any doubt, you can ask in the comment section. So now the next part is to design a microstrip line in CST. As you start the CST, this window will be open. Here we'll start a new template, and in this template we will select the RF and microwave. I'm repeating from the all the available templates. We will select the microwave and RF optical and then antennas. Then select the planar patch slot. Next, keep it as it is. Next, and here you can see dimension. You can fill the frequency, and you can put the frequency later also, and you can put here also, doesn't matter. And after that you can just, you can see here dimension are in frequency gigahertz, and just finish. Now the design window is opened. As we start, see here a untitled 0. The project name is untitled 0. So we can save this project with a name that we want. So firstly, before starting any project, just save it, because if you are not gonna save it, you will lose the updates that you will do in the design window. So here we have firstly saved the project with the name of here I am saving this project with the name of Microstrip line. So after saving the project, first step is to create a substrate. Go to modeling and take a rectangular box and add its name as a substrate. So I am gonna take here variable, not the values. So x minimum to x maximum is ws, and 0 y minimum 0 to ls, and 0 to hs. Ws is the width of the substrate and ls is the length of the substrate, and material I am putting here is a fr4. You can search in the material library. Here is the fr4. You can see the dielectric constant is 4.3. So load it. Okay, now we have to put the value of ws, ls and hs, where hs is the 1.6 mm, that is the height of the substrate. Now put the dimension as given. Now the substrate is created. You can see, to move the design window you can use the components that is given over here. You can use these tools that are given in the below side. And now we have to create the ground plane. So take another rectangular box, ground plane. The ground plane dimension will be same as of substrate. Only the height of the ground plane, that is the thickness of the ground plane, will be 17 microns. This is 0.017 mm. And the ground plane will be placed below the substrate, and the material we will use for the ground plane is copper. And press the OK. Put the thickness of the ground plane, and you can see a ground plane is generated below the substrate. Now next step is to create a microstrip line. So here microstrip line will be created at the center of the substrate. So I am taking the center of the substrate, which is ws by 2, and the width of the microstrip line I am taking here is wm, which is 3 mm. This is the width of the microstrip line, and the length of the microstrip line will be same as of the substrate. And the height of the microstrip line, that is the thickness of the microstrip line, will be 17 micron as of ground plane. So now all the parts are created. We have a substrate with the microstrip line and a ground plane. Here I am gonna show you how you can change the showing windows. Like in go to the windows in view, you can hide your navigation tree, you can get it navigation tree, you can hide the upper component palette, and you can also get it back. Okay, now the next step is to connect a waveguide port. To connect the waveguide port, we have to select the face of the microstrip line where we want to put the waveguide port. So to select the face, we can just enter F, or we can get the face from the go to the pix and select the face and select double click over the face. So now to connect a port, go to the home, macros, solver, ports, calculate port extension coefficient. Now calculate the port extension coefficient and construct the port. You need to calculate the port extension coefficient because it's gonna make a 50 ohm port. Otherwise, if you add the port dimension accordingly, this will not be 50 ohm port, and the impedance of the waveguide port will not be matched with the microstrip line. So likewise, connect the another waveguide port with the another end of the transmission line. Now the two ports are connected. Here in simulation you can change the frequency if you want. As I mentioned earlier, you can put the frequency values later also. Now we are gonna simulate. go to the simulator and start the simulation. And now just wait for the simulation result. Now the simulation is completed. We can check the 1D results here. The S parameters are given. We can see the S11, S21, S12 and as well as S22. From 1D plot you can make a axis maker, you can mark a curve maker over a point as shown in the video, and also you can check the reference impedance. Reference impedance is the impedance that is seen by the waveguide port. So the waveguide port is of 50 ohm, it is seeing a impedance in front of that, it is 49.5. That means the impedance of our microstrip line is 49.5, and which should be of 50 ohm. To get a 50 ohm line, we will change the WM microstrip line width from 3 to 2.95 mm. OK, and press F7 to update the design and again start the simulation. Now the simulation is done. We can check the 1D result for both the value of the WM, that is for 2.95 as well as for the 3 mm. So we can see the reference impedance is improved and it is nearly close to the 50 ohm for the WM is equal to 2.95 mm. So this is done. Now we'll go back to the design. We can check here the field monitors, that is the we can check E field, H field or surface current by going into the simulation and then field monitor. Check the E field and surface current at a particular frequency, that is 2.5 gigahertz. Apply it and then again start the simulator. This part of simulation is not gonna take much time because all the rest part of the simulation was done earlier. It's just a post processing process. So now the simulation is done. By going into the 2D 3D results, you can check the E field for both the port, that is for the first port and as well as for the second port. As well you can check the H field or you can check the surface current as well. Here you can see the electric field for the first port. You can change the value by changing this given graph, and you can check the electric field for second port as well as you can check the H field for, that is magnetic field for both ports, and as well as the surface current. You can see here. So this part is done. Now I will show you how you can export the DXF file. So to export the DXF file, we have to get the local coordinates. To get the local coordinates, we have to go to the modeling, and you can, here you can see, you can put the local coordinate. Go to the local coordinates properties by clicking on small arrow, and in origin you have to put z equal to hs, that is the height of the substrate, that is the upper part of the substrate. We will put into the origin is hs. Now the you can see here the local coordinate shifted to the upper part of the substrate, because this is the portion where substrate and microstrip line both are attached, and we can get the boundary lines for both of them. Now this part is done. Modeling local coordinates are aligned very well. Now go to the modeling. Go to the import export. Here you can see export 2D file DXF. Here you can see this, the red line showing that this DXF file will be exported. So all the boundary lines are in there, and save your DXF file, give an appropriate name and save it. So this was the exporting the DXF file. Now you can export the S parameter as well. So exporting the X parameter, select the S parameter, go to the post processing process. Go to the post processing, go to the import export and export plot data ASCII. It will export a text file for your S parameter that you will need to plot your graph in Origin or in MATLAB or whatever software you want to use for plotting the graph. Okay, likewise you can check here the other parameters also, VSWR, and you can change the x-axis or y-axis value by going into the 1D plot. Here I have changed from VSWR graph value from 0 to 1 for the y-axis, and see here. Now you can just remove the local coordinates, you don't need them anymore, and you can save your project. And if you have any doubt, you can ask in the comment section.